Keith Tanner here from Flyin Miata, and I'm here in my own shop to talk to you about an experiment that I played around with a few years back. And it's up to you to decide whether it was successful or not, but the experiment was active aero. Now, active aero is nothing new. People have been messing around with it for years. The most famous examples are probably the Chaparrals back in Can-Am, and was that the early 60s, I think they were doing that. There was if I remember correctly, there was a Mercedes that used a speed brake, basically a big wing or something that popped up on the back in the 50s, I think, back in the SLR era. And of course, these days it's most likely seen as DRS in Formula One, it's a drag reduction system. I decided to start experimenting with it after following a McLaren MP412C around a series of corners of High Plains Raceway, and I was right behind him. Not for long, but during the corners, and I was watching his little air brake thing, that's the active aero on the back of that thing, dancing around the middle of the corner. And I had my wing on at the time, and I thought that'd be fun to play with. Let's see if I can do something about that. The original plan was to come up with a 3-position system. Because that McLaren used the wing as a speed brake, as an air brake, I started thinking along those lines, and of course, being a Formula One fan, I was already thinking about drag reduction. So the original plan was for a 3-stage setup that would do regular, everyday downforce. It would have a drag reduction where it would lay down flat and go to the lowest drag setup, and a high drag setup which would be used as an air brake. And the plan was to use linear actuators to this. I'm going to warn you, but the project I'm talking about here, this is not a highly evolved, highly successful, and race-proven setup. This is something I was screwing around with this. I got to a proof of concept. I tried it. It worked well enough. Well, you can decide. And then I moved on to other things. So don't come looking to this for an example of how to perfectly build the ultimate drag reduction system or whatever, but take this for some ideas. So I was looking at a 3-position system, and that means using a linear actuator, something like this. And I picked some of these up, and they come with, I'll show you pictures of these, show you close up later. Cute little control boxes, and even a little 3-button switch. And you can set this up so that you press button 1 and it goes to one position, you press button 2, it goes to another, you let go, it returns to 3, whatever. You can set those up. So this is an example of linear actuator. It gets longer and shorter on demand. The problem is that they have a choice of being either strong or being fast, but they don't have the option of being both. This one, for example, will push 110 pounds. It's a dynamic load, but its average speed is ½ an inch per second. That's a little slow. This one, which is really very similar, it's just a shorter stroke model, will do 1.7 inches per second, but it can only handle 34 pounds of load. It's a gearing thing. You've only got so much power in the motor, so you either move it fast with not a lot of power behind it, or you move it slowly with not a lot of force behind, or slowly with a lot of force behind it. So those were difficult. And then the fellow behind the US built Exoset, Warren Van Nuys, I apologize, Warren, if that's not how you pronounce your last name, came up with the suggestion to use headlight motors off an NA. Now, he's not the first one to think of this. ISO Racing has famously built a car with using these motors. There was another endurance racing Lemons team, and I think it did afterwards, that used these motors. But they're a great example of, one, parts that we have available, especially if you're building exosets, and two, a very, very simple implementation. The way these things are wired, they've got 5 wires on, power and ground. Put 12 volts to one wire, it goes to the up position. Put 12 volts to the other wire, it goes to the down position. And then there's a 5th wire that just runs a light. It lets you know that the motor is running. You've seen that on your NA. You've seen this little light that comes on when the headlights are going up and down. So a very, very simple control mechanism. You have no control over the position. It will just continue moving until it gets to where it needs to go. It will move the other direction until it gets to where it needs to go. If you stop it halfway through, it will finish its movement before it goes back again. It's very similar to a windshield wiper motor in a lot of ways. But the important thing is they're available, they're cheap, they're very strong, very durable, and they have a cycle time of about ½ second, 0.6 of a second. So that's what I decided to build it with. Now I'll give you a close-up of what we're looking at. Okay, I'm sorry guys if I wasn't loud enough. I am doing this with an iPhone standing by myself in my garage. So I'm sorry if the intro was not loud enough. If there's something you're looking for, please ask it again. I will try to answer all the questions in the comments. But this was my implementation. I already had the wing. It's a Car of Tomorrow carbon fiber wing, beautiful little thing. I took a spare set of mounts that I had sitting on the shelf and mounted a set of windshield wiper motors to them using the factory linkage with an extra bar on the top that I sourced from McMaster Car. Now, the entire purpose of this was to see if I could test it out without having to make any major modifications. I wasn't going to be drilling any holes in my wing. I didn't want to take any chances on breaking the wing in half. I didn't want to drill anything in it. And I wanted to minimize, basically I just wanted to see, is this going to work? I wasn't going to spend a whole lot of time re-engineering something if I couldn't prove that it didn't work at all. So there we go. Yeah, sound is great now because I'm standing right behind the phone. That's what's going on. Warren is watching. Warren, this is your fault. This is all because of the video that you posted to YouTube that's still there, investigating the control system for these motors. And it's ugly. I'll admit that. That is the purpose of proof of concept, is you're gonna build something that works, but may not be all that pretty. So I've got over here, this has got nylon washers on it because it's a pivot point. And then back here, this is the arm that rotates up and rotates down as the motor actuates. And then it's just attached up here with a rod. Again, the purpose here was to not drill any bonus holes in my setup. Got a question from Josh about the frame of the wing being tied, the wing being tied in the frame. It is attached to the side of the trunk opening. This is the same in the Car of Tomorrow wings that I designed years ago, well, for this car, that Flyin Miata actually sold for a while. It's a very, very strong place to put loads in, and I've got a set of rib nuts in there so I can take the wing on and off easily. So that's not really the purpose of what we're showing off here, but yes, it is tied into a very strong point in the car. This setup has been tested at, well, I don't know, 135 or so, and it's good and strong. So the reason I went with an air brake setup instead of a drag reduction is because, well, this particular car has a pretty good power to weight ratio. It's rocking 466 at the wheels, horsepower. It's got all the torque in the world. So it doesn't really have a lot of trouble pushing itself through the air, but it does put a beating on the brakes. So not only was I thinking about air brakes because of that McLaren I'd been following, but I was also thinking about it because what I really needed help with was getting the thing slowed down. A fellow named Jack Olson, who you may be familiar of, he's got the 12-gauge garage, a beautiful garage in the LA area that a Porsche lives in. He also is a serious racer at Willow Springs. He has decades of experience there. He tried doing the same sort of thing with DRS, and in his experience, it wasn't really effective. The reason being that there just wasn't that much drag from his wing when he was going down the straights. So adding the extra mechanism, the extra weight to get rid of some of that drag, it just wasn't that much to get rid of. Formula One cars can take very much advantage of it because they have so much drag from their extremely aggressive Aero that they can decelerate at 1G simply by lifting off the throttle by Aero drag alone. So Formula One cars have a huge amount of drag. They can benefit from a DRS system. This particular wing is very efficient. The Car of Tomorrow wing was built for NASCAR, so it's built for 120 mile an hour plus ranges. So going to drag reduction wouldn't have helped much. So yes, we have a I don't know how much you guys heard of the initial explanation, but my original plan was to use these linear actuators. But linear actuators, the downside is they either can be strong and slow, or they can be slow or they can be fast and weak. You don't get your choice of both. So I went with Miata headlight motors. They're strong. They're very, very effective, and they're easy to implement. There's just the control strategy is very straightforward. trying to think of where my brain was going with this. I'm not the only person to use these headlight motors in Aero. ISO Racing did one where they used it to add a flap on the roof of a Miata that was lifted up by a single motor, sort of sat on top of where the hardtop would be if they had a hardtop, but it lifted up a little flap under braking, and that thing generated enough low pressure behind it that it would actually open up the trunk lid, which the latch was broken. But coming into turn 2 at Thunderhill, it hit the brakes, and there'd be enough vacuum force by that thing to lift the trunk lid off. There was another Lemons team that built a wing more like this one that was run as an air brake, and they powered it by a single headlight motor, and they've run 24-hour races with that thing without failures. These little motors are tough, and like I said, they're fast. It's 0.6 of a second from full up to full down. Now for control system, I went simple. They're tied to the brake lights. So every time that I trigger the brakes, it switches a relay, puts the wing into high angle of attack mode, and then when I let off the brakes, the wing goes back into normal mode. Now this is not the ideal situation. The reason being that, if you brush your brakes mid-corner, you can have trouble. With your wing, obviously your Aero automatically changing on you. But if you brush your brakes mid-corner, you're probably already having trouble anyway. I'll flip this again so you can see how far it goes. The wing is very much going into stall, which means very high drag, which is the point. But it doesn't mean zero downforce. It means we're still getting some downforce, but it's just maybe not as much as the potential at peak. Now I have rewired. I don't know if you can see me or not. I have no idea. I've rewired in just a little switch that lets me activate the brake lights remotely. Normally it's just obviously off the pedal. And I do have a switch inside that allows me to turn this on and off. But brakes on, there are the lights, brakes off. So it's very quick to change back and forth. If you just brush the brakes, it'll do something like this, which is a little weird. Certainly teaches you to use the brakes purposefully, I'll tell you that. My driving style, this works well. I don't tend to trail brake very much. I tend to get the car settled under power. But depending on your driving style, you may want to implement it slightly differently. But that's how it was done with this. Just a simple relay, triggered to the brake lights, and there you go, active wing. So how well does it work? Well, my testing was based at High Plains Raceway, which is a high altitude track, so there's a little less air density than you get at the sea level tracks. But it's got a fairly long, fast back straight, followed by a series of braking zones. But there's an initial braking point that in this car is in the 135 range, something like that. I forget what it is. And what I was looking for was more stability, more braking power with that setup. And what happened is more stability, which is exactly what I was looking for. It felt great. The reason for that is when you go into stall, when the wing goes into the high range, the high position, you're stalling it, but you're also moving the center of aerodynamic effort way back. It's like throwing out a drogue chute. All of a sudden, the Aero, you're pulling on the back of the car, basically. You're helping keeping it stable. The Lemons team that ran one of these things in the wet, in a 24-hour race, says that they were far more stable under braking. They could brake much closer to their dry numbers with the active wing turned on. And and there was much more confidence on the part of the driver. Now there are some problems. Testing. I'm going to get to testing in a moment. There are some problems. One is, as soon as the wing goes into the high mode, you completely lose your ability to see out the back window. Let me turn this on here. Let's go into drag reduction mode. Whoops. Yeah. So this is not good if you're if you're trying to figure out what the guy behind you is doing. It's not a good situation. I'll get into some of the theory in this in a moment. So that was one definite problem with it. I never was able to get actual numbers on how well it was working because my data acquisition system started giving me trouble when I was running this thing at High Plains. I don't get to run High Plains all that often because it's 5 hours from here, and I never got any hard data on it. But I can tell you from the seat of the pants, it did work very, very well in terms of adding the stability and making the car feel better under braking. Now, how much force is needed? I wasn't sure when I built this how much force was going to be needed, and I didn't want to drill any holes in my nice fancy wing. So this is set up, these little motors put out an incredible amount of force. They can really lift. Like I said, 135 miles an hour. There is no discernible delay in this thing lifting up. If you wanted to use a linear actuator that wasn't quite so strong, you could basically move your pivot points a little closer to the center of balance of the wing, which is about a quarter of the way back. It's somewhere around here. So you could put a pivot here and then force on this side or drop it down or something. So that's how you can make up for the that's how you can make up for the slow speed of the actuators or the limited stroke of the actuators. Would be to move closer to that. Again, this is just a proof of concept. I was trying to see if I could make it work. The answer was yes. Now, of course, as soon as you do something like this, everybody and their dog on the internet starts talking about how you could integrate GPS and about how you could make it as complicated as possible with all sorts of feedback and multiple positions. And yes, that is totally true. You could make it much more complicated. This is just a proof of concept to see if it would work. And the answer is yes, it did work. Things like Kyle's suggestion here about using a camera for a rearview mirror. That's possible. But again, I was just looking to see, does this work out? And the answer is yes, it worked out. So that's what I needed. Let me check my notes here. I've got some questions that people have asked previously. Where can I get one? Well, you can make one. This is not an actual project or product. No one is making a system like this because it's not legal in most race situations. But you can always make your own. This is not a complicated thing. Every part needed came off a Miata, with the exception of this push rod on the that came from a McMaster car, and everything else is basically just was on the wing already, or came from the Miata. You can see the actual. I used the trunk lock hole for the wiring to come out of, and the wiring is a little bit of a dog's breakfast because, like I said, it was simply for testing. Now, this is something I built back in 2013. I have not really investigated it since. The reason being that, one, to answer the question, yes, they are NA headlight motors. I've shown them a couple of times, but yes, those are NA headlight motors. They are strong, they are fast, they're easy to control. About a half second from up to down. So yes, Miata headlight motors. I never went any further with development because, one, I needed to use the car for other things. It actually went down shortly after this build so I could put in the bigger motor. It was only running the 350 horse V8 at that time. And also because I simply had other things I needed to do. I was spending more time working on development for suspension, that kind of thing. And it was fun. It was weird. And it gets lots of attention in the paddock. I will warn you, though, that if you do go and pull up in the paddock in one of these things, you will get lots of people asking questions and then telling you how you could have done it better. That's another reason I got rid of it, honestly. I got sick of people telling me how I could have implemented a full-on CFD proven proof of concept. Whoops, here we go. So for those who are just new to this whole thing, these are triggered by the brake lights. So every time you hit the brakes, the thing goes into stall mode. If you are worried about a light brush of the brakes, just flash the lights and having this thing cycle. A way around that would be to use a pressure switch in the braking system so that it only comes on under a certain level of braking. In this car, if I'm braking like I mean it. So generally speaking, that is not much of a problem. Let me see. I'll cycle this for you guys again so you can see it going. Again, I'm using a switch that simulates the brakes. I'm just turning the brake lights on here, but there you go, full on braking, and then off the brakes, back on the gas. You've got your downforce back again. And again, this stalled version like this is not without downforce. A stall is basically once you go past the point of maximum downforce, technically. So there is still downforce, or lift. There is downforce going on here, not as much. Mostly what you feel is almost like a big hand grabbing the back of the car and keeping it stable and pulling it backwards for you. As long as you don't mind missing out on what's behind you. Now, a future version of this that I had been thinking of, was to put the motors inside the trunk, because aerodynamically speaking, this sucks. You know, you don't really want a bunch of stuff hanging out just underneath your the functional surface of your wing. There's a lot of mess in here right where I don't really need it. So the next version would have put the actuators down inside the trunk and run push rods up through the trunk lid. That would have meant cutting holes in the trunk lid, and I didn't really feel like redoing that at the time. I have a spare trunk lid waiting for that, but someday, if I ever get around to doing this again. Every time I did use this on track, I always made sure the corner workers knew about it, because I did not want to get black flagged in for a mechanical failure with my wing flapping all over the place. I can tell you that the first time I did it, told the corner workers, I got a big round of thumbs up from everybody on the way in. The corner workers love seeing something like this going on. And there is video on the Targa Miata YouTube channel. That is youtube.com/Targa Miata. There is video of this thing being tested at High Plains Raceway, showing the view of the wing at 135 miles an hour when it triggers. If there are any questions, I'd be happy to answer them. Let's see. Just looking at the questions that came to me here. Do I have ABS? I don't, but that's not really a factor in this particular setup. James May is asking about using push-pull cables instead of push rods. Jack Olson experimented that on his implementation. He was doing a DRS implementation, and I think he found there was too much trouble with slack and with stretching. A pull cable would be tough, because you got to remember that all the force in this wing is down most of the time. So I'm not sure how you would actually force it into a high level of attack with a cable. That would be an interesting engineering challenge, but you could try playing it with cables. I would be worried about stretch, because there are a fair number of forces on this thing at speed. Things are moving around. Little hydraulics is another possibility. You could go with that. Again, this is a proof of concept. I wanted to see if it would work, and the easy way to do that was to strap headlight motors to the side of an existing wing upright, and not to come up with a high-pressure hydraulic system that wasn't in the car already. These are the hydraulic actuators that were going to be part of version 2, or still will if I ever get a chance to do it. This is a 2-inch stroke hydraulic cylinder. This particular one's a fast one, so it'll do 1.7 inches a second, and it'll lift 34 pounds. So you definitely have to get that one close to the center of pressure. This is it's a longer one, but it's a slow and strong 110 pounds of lifting force, but only half an inch a second. So this one, you would definitely have to get near the middle, and the end result would be both of these things, that they would be pretty close to the same sort of effect. They do come with this cool little controller, though. You can get this little thing, so you can say if you want your DRS, you could copy this thing. It works better right way up. There we go. So this could be DRS, this could be normal, this could be high drag. So it would be much easier to program these things to do a 3-position if you had a wing that was high drag enough, or a normal downforce setting that was high drag enough that you would benefit from DRS. First, you've got to be creating some drag for that to be an issue. My Car of Tomorrow wing is not a draggy wing, so that's not a problem I have. I have a lot of horsepower, so again, not a problem I have. So I didn't go that direction. But this is the little controller you can buy for these things. Made by Concentric International, dual linear action. There you go. So that's what this part is. Nathan Werner has just posted a link to something, I don't know what, but a video that hopefully is one of these things actually working, because there certainly are another couple of applications of this wiper motor actuated wing around there. And as I mentioned earlier, they have survived a 24-hour race in Lemons, which is pretty impressive. These little motors are tough, and they're everywhere. I found a couple just digging around my shop looking to do this demo. Where can I get one? You have to make your own. So, yeah, I think I've covered most of the stuff, most of the questions that were sent to us ahead of time. Thank you, Nathan. Nathan has linked the active wing test on track, so if you guys want to see that one, there's a high-speed version of there. It's not the world's most exciting cinematography, but you can see the proof that the thing does move when it's going. We do have a question here on if Flyin Miata is planning on bringing more Aero bits to market. We are certainly looking at options. We are, as you may have seen last week, we added those fender vents to get some of the hot air out of your wheel wells, the left lane design fender vents. We are always evaluating different products. I'd love to get a wing in the catalog. We at the moment do not have any options for that. And if we do put a wing in the catalog, I don't know if we'll necessarily have an active component, but I'd love to see someone play with it. So that is about all I've got to say about this, the active wing proof of concept. I'll cycle this thing another couple of times just for fun. Okay, more activation. This is just like showing off the V8 car. Everyone wants to hear it run. Everyone wants to see everybody wants to see an active wing activate. So again, I'm controlling this with, normally this is triggered by the brake lights. I'm controlling this with a switch that I've wired in to override the lights, simply because it's easier than me jumping in the car and hitting the brake pedal. But this is the equivalent of what's going on. So brakes on, see the brake lights come on, wing goes down with it, and there we go, there's the low setting. And then my little connector just came off, there we go. All right, I'm gonna stop playing with that for a while because my switch just fell off. I was using alligator clips. Anyway, so there you go. If anybody else out there goes and tries to do something interesting with Active Aero, please post links in the comments. Send us email. We love to see this kind of stuff. It doesn't have to be something that can be sold for a bunch of money to everybody. It's just something cool and interesting. If you're playing with Active Aero, if you have a plan, if you put something together, definitely share it because I love seeing that kind of stuff. So that's it for this week. I'll see you again next week at 2 o'clock Mountain Time. Let me do one more check to see if there's any questions. I want to make sure we answer the questions. And yeah, there's one of the questions. Yes, this is Keith Tanner. During the current stay-at-home orders, I am shooting these videos solo at home. So if I seem a little distracted and the camera work is a little less smooth than what you're used to, I apologize for that. But we're trying to make up for that with good content. Again, we will answer any questions that you put up in the comments. We will do our best to get the info to you. If you are looking for instrumented track times, 70 to 0 braking tests, those have not been performed on this thing. I might do that in the future, but at the moment we don't have any actual numbers. This is just an implementation of a dumb idea, a good idea, an idea. So that's it, folks. We will see you next week. Thanks for your attention.